Hi, I'm Sumit Ahmed Sharif from Data Triumph, and my contribution to the project was data collection and visualization.
Hi, my name is Saklen and I am from Data Triumph, and my contribution to the project was data processing and model training.
Problem statement. So what is market basket analysis? Market basket analysis is the identification and analysis of buying patterns of customers in order to maximize a company's profit. With the advent of new technologies, it has become easier to log the transactions of customers and to analyze it. Mining purchasing patterns allows retailers to adjust promotions, store settings, and serve consumers better. The traditional method of market basket analysis uses the a priori algorithm and association rule mining. This process consumes a lot of time generating rules. Our goal was to use an ML model for analysis. It eliminates the overhead of rule generation, and the only time spent is the time it takes for the model to learn the pattern. Now, coming to the dataset. We have made use of the Instacart market basket data from Kaggle. Instacart is an American company that operates as a same-day grocery delivery service. Customers select groceries through a web application from various retailers, and the order is delivered to them by a personal shopper. This dataset was published by Instacart for a challenge posted on Kaggle. The dataset consists of separate files on aisles, departments, prior orders, and products. The dataset consists of about 3 million grocery orders from more than 200,000 Instacart users, with each user ordering multiple times. Our second dataset is from a bakery, which consists of about 10,000 transactions with 95 unique items. We have made use of the bakery dataset for initial testing of the models due to technical limitations. We were not able to run the models on Instacart dataset. We then moved on to Kaggle and wrote kernels to work with the Instacart dataset. Let's have a look at a few visualizations. Reorder ratio. We can see from the graph that the reorder ratio is high for items of daily consumption. For example, bakery items, eggs, beverages, meat and seafood, and organic produce have a very high reorder ratio at a range of about 0.65. This gives us an idea as to what kind of products have a higher probability of being bought. And items with a high probability of being bought also have a high probability of being bought together. For example, if somebody's bought eggs, that's a high chance that they'll buy organic produce as well. Let's have a look at the reorders. From the graph, we observe that about 24,000 users have reordered only 4 times in a year. This could be because they have been purchasing items which last for a longer duration of time. At orders above 15 or 16, we notice that the magnitude becomes pretty constant at around 5,000. These are the customers who buy at frequent intervals. Hence, it is deduced that a lot of users prefer to buy quarterly and to last for a longer duration. Also, there's a huge number of people who buy regularly. This bar plot shows the top 20 bought items. We see that all these items belong to the organic produce department, concretely proving the point we made in the former slides.
Now coming to the approaches, as we saw from the previous section that there are a huge number of products that are being reordered multiple times. As the dataset had information about whether a product will be reordered or not, this data was in turn used to predict whether a customer will reorder the product or not. This information can in turn be used to stockpile products that are likely to be reordered multiple times. Thus, the approach includes 3 steps. The first step includes dividing the dataset into training and testing data with 70-30 ratio. The second step includes training a model. As it is a binary classification problem, a logistic regression was suitable for this problem. But to test it against different models, a multi-layer perceptron model was also used. The third step includes model testing. When the logistic regression model was validated, it gave an accuracy of around 60%, with F1 score to be at 75%. When the multi-layer perceptron model was validated with the testing data, an accuracy of 62% was obtained. Even though the accuracy of multi-layer perceptron was higher than the regression model, the amount of time taken to train with the multi-layer perceptron model was higher than the regression model, and it required more hardware resources. The previous section talks about whether an item will be reordered or not. This information, in addition to collaborative filtering, is used to recommend products to the user. This is because if an item is reordered multiple times, it in turn indicates that the item will be picked up by more users more oftenly. The steps include data processing and then the actual recommendation system. Now coming to data processing. The dataset was merged to get the information about the product name as shown in the snippet to the top right corner. Once the datasets were merged, only those rows were considered in which the products are reordered more than once. These are called as high demand products. The snippet to the bottom right corner indicates whether the product is in high demand or not. Now coming to the recommendation system. Once the information about the products that are in high demand are obtained, the user information was extracted by merging the orders dataset to get the user ID information, as shown in the snippet to the top right corner, which is in turn used to generate user-user similarity matrix. Once the dataset was merged, the number of times a specific product was ordered were extracted by grouping on the user ID and the product ID and converted to a single row, which also indicates the list of items that was bought by that user. A user-user similarity matrix was generated using cosine similarity measure from the user product matrix. A product user matrix was also generated to get the list of users that ordered these specific items. Thus, the item user matrix and user similarity matrix is used to recommend top 5 products to a specific user by performing a dot product between the item user matrix and a vector which contains the user that are similar to the given user for whom the recommendation is being performed. Performing a dot product between the user similarity matrix and item user matrix will generate a score for each item. Thus, the product with the max score will be the one which is bought by most of the users that are similar to the current user for whom the recommendation is being performed. The snippet of code to the right side generalizes the entire procedure. The image at the bottom shows the recommendation that is done by a recommendation system for a specific user. Validating a recommendation system is a problem of its own, as the customer's choices are dynamic in nature, and even though items are recommended to the user, it is the user's choice to pick up the item. Another major problem in the recommendation system is determining the size of the basket, as it is dynamic and varies from user to user, and it is also a problem of its own. Thus, in the end, we would like to thank our mentor and data analytics teacher, Gauri ma'am, for her support throughout the project. Thank you.